In an earlier challenge, I created an immutable bank customer and a bank account class. I'll be building on that code here. If you didn't do that challenge, let me encourage you to go back and work through it. But if you prefer, you can also get the code in the resources section of this video. I ended up with two classes as shown here. The getters, constructors, and toString methods aren't shown on this diagram. These are the classes we'll be starting with in this challenge. Let's imagine that we work on a team with different developers. One team creates the data transfer objects, DTOs, which will be used by a framework to retrieve data from and commit data to a database. Let's assume they use software to generate these classes from their data model. We want to emulate this, so we first want to create a transaction class in a dev.dto package that will mirror a data table. This class should have the fields shown here, and you need to include getters and setters for all fields. Data transfer objects generally have both in order to support two-way communication with database entities. Also include a constructor that takes all fields for ease of use. For this challenge, you'll modify your bank account class. First, you'll want to change the balance so that it's mutable. Include a transaction collection. I'm showing a map on my class diagram, but if you want to use another collection, that's good too. Provide a getter or accessor method for the transaction data. Provide a method to adjust the balance and add the transaction data to the transaction collection. I'll be doing this in a single method called commit_transaction as shown. You'll also need to modify your bank customer class. Return the customer ID as a 15-digit string with leading zeros. Design this class so that code in other packages can't instantiate a new bank customer. Return a defensive copy of the accounts from the getAccounts method. Include a getAccount method to return just one account based on account type, either savings or checking. Assume a customer will have one checking account and one savings account. Next, you want to create a bank class that has a routing number and a collection of customers as well as an integer that holds the next transaction ID to be assigned. You should be able to look up a customer by a customer ID, a 15-character string. Transaction IDs should be assigned by using the last transaction ID field on this instance of the bank. A negative amount is a withdrawal and a positive amount is a deposit. Don't let the customer's account balance go below zero. In the main class's main method, create a bank instance and add a customer. Let a client obtain a bank customer instance by a customer ID and review transactions from a single selected account. These transactions should not be modifiable or susceptible to side effects. You should only be able to perform a withdrawal or deposit of funds through the bank instance, passing the customer ID as a string, the type of account this transaction will be processed on, and the amount. In other words, the main method should not have access to the commit transaction code on the bank account itself. You might want to leave this diagram up as you're coding your own solution to help you see the big picture. Okay, so it's time for you to try this out and to modify your banking application as I've described here. Feel free to design your own model if you want. When you're done, or if you find yourself struggling, come back and we'll walk through it together. Pause the video now. I've reopened the Immutable Challenges project from the first challenge in this section. In this project I have a package, dev.bank, that has my bank account and bank customer classes. I designed these to be immutable, but now I want to let customers withdraw or deposit funds and need to keep track of each transaction. I'll create the transaction class first, emulating code that might get generated by tools using database tables to produce them. I want this to be in the dev.dto package. This class has 4 fields. The routing number unique to a bank. The transaction ID, that would be unique within each bank instance. The customer ID, here it's an integer. The amount of the transaction, this is a double and could be negative. Some DTOs have constructors and some don't. A reminder that DTO stands for Data Transfer Object. I'm going to include a constructor with all 4 fields and I'll generate that. Frameworks that generate DTOs include getter and setter methods for every field, so I'll generate those. I'll include a toString method, generating that but selecting no fields, and I'll replace the generated code. I want to return a formatted string in its place. I'll start with a 15-digit zero-field routing number, followed by a 20-digit zero-field customer ID, then a 15-digit zero-field transaction ID. Lastly, for the amount, 12 digits, zero-field, with 2 digits for the cents. That's our DTO. That'll be packaged with our banking code. Next, I'll work on the changes to my bank account class. First, I don't want balance to be final, so I'll remove the final keyword. I'll add a collection of transactions, and of course I have many options to choose from for this type. I could make this an array, a list, a set, or a map. I'm going to go with map in case I ever want to look up a transaction by its transaction ID. I'll use long as my key type, so the wrap-along, uppercase there, and transaction, our DTO, is going to be the value type. I'll call it transactions, and I'll initialize this to a new linked hash map. It makes sense to have the map ordered by the order they were added. I'll generate a getter for that, placing it after getBalance. I'm not going to just return transactions here. Instead, I'll return an unmodifiable collection to try to safeguard this data. Since my field is a map, I can use the copy of method on map, passing it my transactions. Finally, I want to provide a way to change the balance on an account. I'll call this method commit_transaction. I'll make it package private, meaning only classes in this package can call it, so only the bank or bank customer classes will be able to call it. I'll pass the bank routing number, the transaction ID, the customer ID, and the amount of the transaction. In this code, I'll assume validation occurred already, and I'll adjust the balance. Remember, a withdrawal will come in as a negative number, so I can simply add the amount in either case. I'll also create a transaction and put it in this account's map. My customer ID is a string with leading zeros. Here I just want to pass the integer value and let the transaction class format it in its own way. Okay, so that's it for the bank account. Next, I'll go to my bank customer class and make the changes for this class. First, I want to make the constructor package private, so I'm not going to specify any access modifier on this constructor. I'll remove the public access modifier that's there now. I have an error because I was using this constructor in main. I'll fix that shortly. Right now, I'll add a getter for customer ID, putting that under getName. I'll change this to return a 15-digit string. To do this, I'll change the return type to a string and return a formatted string. Next, I want to change the getAccounts method to return an unmodifiable collection by using the copy of method on list this time. This will prevent any clients from adding, deleting, or reassigning accounts, among other things. Lastly, I want to be able to get a customer account by the account type. I'll place this method after the getAccounts method. I'll make this public, returning a bank account, and I'll call it getAccount. It will take an enum constant and account type as the parameter. I'll return null to start with. I'll now add code to loop through my list of accounts, returning the first account that matches the type passed. This isn't realistic for an actual bank, because you could have different multiple checking and savings accounts, but let's keep this simple. My code isn't compiling right now because of the code in the main class's main method, as I mentioned previously. I made the bank customer constructor package private, so I can't instantiate a class from this method. What I'll do so the code compiles is just set Joe to null for now. I wanted this code to compile because I'm going to end this video here. I've got my transaction class, and I've made the modifications to the bank account and bank customer classes. In the next video, I'll be creating the bank class and testing my bank application code, so I'll see you in that next video.